Hello all, and welcome to the 2019 edition of our machine learning and AI-focused AWS Innovate online conference. My name is Olivier Klein, and I'm heading up the emerging technology space in Asia Pacific. Together with Seva Subramanian, VP of Machine Learning at AWS, we will take you through all the new and interesting AI and machine learning services at AWS and talk you through exciting use cases. The AWS Innovate online conference is designed for data scientists, IT executives, IT professionals, data engineers, and developers who are looking to bring new ideas to reality. We will dive deep into many different areas of the AI and ML space with 20 over plus breakout sessions across 6 tracks delivered by our AWS experts. Now, intelligent computer systems and machine learning models have been around for a while, but what has changed? The entry barrier to get started with machine learning, build AI models and run them cost-effectively has been dramatically lowered. And the result? Machine learning is ubiquitous. We are surrounded by it in our daily life pretty much everywhere. If we think AI, we might immediately turn our attention to all the exciting development done in the space of autonomous vehicles or smart or intelligent chatbots and assistants. But let's also not forget about how most platforms now run intelligent recommendation engines or prevent fraudulent activities using machine learning. Every time you swipe that credit card somewhere, probably a machine learning model behind to identify if the transaction was valid. Fulfillment centers, such as the one of Amazon, are often completely automated using robots that use AI algorithms to plan their routes effectively and make sure your parcels arrive on time. We start to see computer vision being used to make better decisions in the space of healthcare or identify anomalies in various manufacturing processes. In the food and beverage industry, companies build models to predict demand and reduce food wastage. At some places in the world, we board an aircraft using facial recognition and, yeah, of course, emails, well, those spam filters, guess what? Machine learning. But overall, there's an interesting trend. I believe that the interfaces to our digital systems of the future are no longer going to be machine-driven. They're going to be human-centric, because we can build neural networks now that can execute human interfaces to our digital systems. Target is to establish a normal human communication, and it might be voice, it might be vision, it might be touch. And these are the areas that have seen a lot of adoption lately, primarily due to the space of deep learning and, of course, cloud computing providers such as AWS. Not too long ago, building intelligent voice processing or computer vision models was no easy feat. But now, with the help of AWS, any of our customers can get access to these technologies without any prior machine learning or data science expertise. We provide you with the broadest and deepest set of machine learning and AI services for your business. And, of course, being customer-centric, we are focused on solving some of the toughest challenges that hold back machine learning from being in the hands of every developer. We have a large number of customers using AWS for machine learning. And we've been making huge investments in the space for 20 years. It's important to remember that many of the capabilities customers experience with Amazon are driven by machine learning and AI models. Our recommendations engine is driven by ML. In our fulfillment centers, the picking routes are optimized by ML. Our supply chain, forecasting, and capacity planning are informed by machine learning algorithms. Alexa is fueled by natural language understanding and automated speech recognition deep learning. Our drone initiative, Prime Air, and the computer vision technology in our new retail experience, Amazon Go, are driven by deep learning. We have thousands of engineers at Amazon committed to machine learning and deep learning, and it's a big part of our heritage. In today's conference, Swami and myself will provide an overview of all the possibilities AWS provides you for your machine learning and AI journey. After that, we'll break out into a variety of different tracks. If you want to understand how some of our customers build intelligent machine learning models on AWS, or what algorithms to choose, you should have a look at the applications of machine learning breakout track. A deeper dive into our Amazon SageMaker service, its inbuilt algorithms and reinforcement learning, attend the build and deploy your own ML models track. If you prefer to use Amazon's fully managed AI services to make use of voice, language, computer vision, personalization, or forecasting services, then attend the fully managed AI services track. Building your own machine learning models often requires peripheral components such as data lakes, serverless deployments, or data labeling processes. If you want to know more about that, attend the end-to-end machine learning track to hear about it. If you rather want to follow some live coding and hacking to build machine learning models, turn over your attention to the Twitch live building session. And lastly, we'll close up the conference with a few interesting live demonstrations about robotics and automation. As always, don't be shy to ask any questions through the online platform at any point in time, so our AWS experts can help you. And for that live demonstration at the end, well, maybe your comment that you provide could help us to improve the demo live on the fly. Now, without further ado, it's my absolute pleasure to introduce Seva Subramanian, VP of Machine Learning at AWS, to take us through all the exciting new services and features on the platform. Swami, over to you.
Thank you, Oliver. Hello, everyone. Really excited to be here today talking about machine learning at AWS. Our mission at AWS in the machine learning team is to put these transformative machine learning capabilities in the hands of everyday developer and data scientists. Said it another way, we want to simplify machine learning to make it really boring. We want to make it easy for all developers, irrespective of the skill levels, whether they are experts, data scientists, to application developers, and so forth, to embed machine learning as part of their everyday applications. And one of the key reasons why now you see so much talk about AI and machine learning of late is because AI is experiencing a renaissance in the cloud. If you look back at the history of machine learning technologies, machine learning has been around for more than 50 years. And in fact, one of the reasons why machine learning is now starting to get rapid adoption is because cloud makes it really easy for you to build machine learning technologies. Because AI technologies require lots of data and lots of specialized compute resources to adapt and apply these machine learning algorithms to train and build these AI systems. And this is where cloud services like S3 makes it really easy for developers to store huge amount of data in a reliable, secure, and cheap fashion. Similarly, developers can rent their GPU compute instances on demand as well. That is one of the reasons why even we have analyst firms estimate that enterprises that are looking to transform themselves and then transform their underlying applications, more than 40% of these digital transformation initiatives are going to be AI-driven. That means we are seeing on a daily basis that many enterprises are going to be using AI technologies to transform their underlying customer experience. They are also going to use AI and machine learning to optimize their supply chain and do better forecasting. Similarly, they are going to be using AI ML to build innovative applications as well. Now, let's take a look at actually the AWS machine learning stack. One of the key things I mentioned earlier is that we want to make machine learning available for all developers, irrespective of the skill levels. To that end, in AWS, we provide 3 tiers of services. To begin with, for expert practitioners, these are folks with advanced degrees in machine learning, we provide machine learning frameworks and infrastructures. There, we provide state-of-the-art GPU and CPU instances, and we support not just one framework, but we support all popular deep learning frameworks like Tensorflow, Apache MXNet, PyTorch, Chainer, and so forth. So if you're a data scientist, if you're really passionate about TensorFlow, you can actually start using it. Or if you're really excited about using PyTorch for text processing, you can use that. And we provide the best-in-class hardware and software infrastructure. Now, if you're a machine learning developer who want to build state-of-the-art anomaly detection algorithm for your application, or if you want to build a recommendation engine, or if you want to build a text processing engine, and you have a lot of your data or data lake stored in S3, now you can actually use our machine learning services like SageMaker, which makes it really easy for developers to build, train, tune, and deploy these machine learning models end-to-end. And finally, for application developers who have no ML experience, we have a whole lot of AI services, right, from like computer vision services like recognition or translate or speech recognition and text-to-speech services like Poly and the chatbot services like Lex as well. So that's kind of an AWS machine learning stack in a nutshell. Now, before I get into many of these use cases, one thing I wanted to start off by saying is we have launched many of these services in the past 12 to 18 months. And one of the things we saw is that there is a rapid adoption of machine learning capabilities happening in AWS. In fact, more machine learning happens on AWS than anywhere else in the cloud. We have tens of thousands of active developers running machine learning on AWS, and there is a 250% growth year over year. And we have more than 8 out of 10 TensorFlow workloads in the cloud run on AWS. Now, when you look at the real customer usages in terms of who are all using it, we have all the way from actually like financial technologies with customers like Intuit and Moody's, to real estate with customers like Zillow, to healthcare like GE Healthcare, to transportation and like Convoy, or to actually self-driving car startups with companies like Too Simple, or to fashion industry like with customers like Stitch Fix. That's one of the reasons why we say that more machine learning happens on AWS than anywhere else. Now, what makes us different? Because there is a whole new actually set of providers talking about AI and machine learning. But one of the unique things about AWS is that we are uniquely customer focused. 90% of our roadmap is defined by customer feedback, and the other 10% is us reading between the lines of what customers tell us and so forth. And to that end, by listening to these customers' roadmap, we aggressively innovate and deliver. In fact, last year, we had more than 200 new machine learning launches in a given year. That is one of the reasons why we have the broadest and deepest set of machine learning capabilities more than any other provider. And one example of an amazing customer outcome achieved by one of our customers is GE Healthcare. So GE Healthcare, using Amazon SageMaker, developed a machine learning model that can learn from thousands of medical scans, such as chest x-rays and head CTs and so forth, and understand what's going on in advance of expert physician levels. This means that they can detect cancers and problems earlier than before they become symptomatic to the patient. Right. Going from healthcare to sports, it is football season in America, and one of the interesting customer use case for machine learning is done by NFL, the National Football League, which has more than 180 million fans worldwide. And about 17 million of those fans trek to stadiums each season, which means over 90% of NFL fans are catching the games on TV, online, or mobile. That's one of the reasons why NFL games represented 37 of the top 50 highest rated television broadcasts of 2017. And NFL has been looking to use machine learning by leveraging many of these stats and building advanced predictive models. In fact, 1 week of NFL games now creates 3 terabytes of data. And NFL uses Amazon SageMaker to analyze telemetry data to predict plays and look at actually various different movements and so forth. So computations that could take months to refine now takes only weeks or days using Amazon SageMaker and AWS stack. Now, going from sports analytics, now let's take a look at finance industry. So one of the our customers, Siemens, they use TensorFlow on Amazon SageMaker, and Siemens Financial Services developed a natural language processing model to extract critical information to accelerate investment strategies, due diligence. And by using SageMaker, they were able to reduce the time to summarize these diligent documents from 12 hours to 30 seconds. Think about more than an order of magnitude difference in being able to get to decisions using machine learning and SageMaker. Now, from finance industry, now let's take a look at communications. One of the leading communication provider is Vonage, and Vonage uses Amazon Lex and Poly to develop a natural language-driven conversational applications that could respond to customer requests with real-time and contextual intelligence, improving the response time and quality of service at the same time. Now, that is one of the reasons why we always say we are focused on solving some of the toughest challenges that hold back success with machine learning. As you see more and more customers adopting machine learning and integrating into their applications, the more we engage with customers, some of the patterns we commonly see are they face three of the biggest challenges. One is cost, and two is data, and three is ease of use. When it comes to cost, the biggest cost is that as customers build out these machine learning models, it is really hard to make these predictions at scale and still actually keep the costs under control. And that is one of the reasons why we are launching Amazon EC2 P3DN instance. This is the largest P3 instances optimized for distributed training. So last year at re:Invent, we introduced P3DN, and this is 14 times faster than the P2 instances. And now it reduces the machine learning training time significantly, and it leads to better GPU utilization. In fact, it has 4x more bandwidth than P3, and it has 2x more GPU memory than its P3 predecessor as well. So now what used to take possibly like weeks, now using P3DN will be significantly reduced to days as well. Now, when you look at actually the machine learning workloads, while prediction gets a lot of, training gets a lot of attention, when you look at the training, one of the most popular frameworks in the deep learning ecosystem is TensorFlow. And in order to take advantage of all the data that you could actually use to train your TensorFlow models, what typically customers end up doing is to scale their entire training cluster by deploying across more and more GPUs. And when we engage with customers who build TensorFlow models at scale, one of the things we see is that as they scale their TensorFlow training cycles upon hundreds of GPUs, TensorFlow, the stock TensorFlow models do not scale linearly. In fact, when you try to run a training cluster across 256 GPUs, they get a scaling efficiency of only 65%. Now, that is one of the reasons why last re:Invent we launched AWS optimized TensorFlow, which provides a remarkable jump in scaling efficiency where it goes from 65% to 90%. And what we did here is to optimize the underlying messaging infrastructure so that as customers scale from 8 GPUs to 16 or 32, all the way up to 256, you don't drop in the efficiency. That means your training cost significantly decreases. And more importantly, it's not always about the cost. It is also about being able to reduce the underlying training time. Where if you are actually trying a computer vision model, what used to take 30 minutes on some of the most popular computer vision models like ResNet and so forth, the leading training time was 30 minutes. And now with AWS optimized TensorFlow, now it has been cut down to 14 minutes of training time. Now, while training gets a lot of attention in machine learning, in fact, in reality, the inference really typically tends to be the 90% of the cost. This is because while you train your models probably once a week or twice a month, in reality, you're going to be running these models every second of the day and every day of the year. So that is one of the reasons why last re:Invent, we launched Amazon Elastic Inference. This is Elastic Inference is a brand new capability that is aimed to reduce the deep learning inference costs up to 75%. where similar to what EBS has done for storage, now with elastic inference, you can provision these accelerators and you can attach it to your EC2 instances. And as you scale up your inferences, you can actually add more accelerators on demand so that if it is Q4 and you have more customers using your system, then you can add more capacity to match the demand and scale down when your demand decreases. So you exactly provision what you need and nothing more. That is one of the reasons why we have customers like Autodesk or EagleView or GumGum already excited about using elastic inference. Now, it has never been easier, faster, or more cost-effective to train machine learning models in the cloud. And while training gets a lot of ad time in media and so forth, in reality, predictions drive most of the cost. In fact, in Amazon's experience, what we see is training typically takes only 10% of the entire cost of running a machine learning application. And inference is where you spend more than 90% of its underlying cost. And this is because when you think about it, training, the data scientists or developers, typically, they train a new model probably once a week or twice a month and so forth. Whereas you build a model and run it every single second of the day and every day of the year and so forth. That's one of the reasons why inference typically makes up more than 90% of the underlying cost. Now, let's take a look at what are some of the challenges of running prediction in production. Now, one of the first things is that different machine learning algorithms require different amount of compute power. Like classic machine learning algorithms might need very simple compute power compared to like deep learning frameworks might need a whole lot of underlying GPU compute power to run these models. Similarly, elasticity is another major need for running these predictions. If it is Q4 in Amazon, we actually have a peak time during shopping. So that is one of the reasons where we need to scale our machine learning infrastructure to meet the customer demand. But once our shopping season winds down, different applications might start scaling down. So in this scenario, you do not want to scale up to your peak and leave the peak provision all the time and pay for it. Now, let's take a look at the second blocker, which is data. So when you look at actually what it takes to build a machine learning or AI system, it all starts with data. For example, last year, we talked about why machine learning was still complicated. If you look at the entire workflow or end-to-end cycle of what it takes for a machine learning developer to build a machine learning system, they had to go through a series of steps, right from they got to collect and prepare the training data. Then they got to choose and optimize their machine learning algorithm. Then they got to set up the environment and to train and tune the model and deploy it in production and scale it. Now, that is one of the reasons why 2 years ago, we launched Amazon SageMaker. It is an end-to-end system that makes it easy for developers to build, train, and deploy machine learning models. SageMaker addresses each of these problems using well-built solutions to make it easy to collect and prepare training data. We have pre-built notebooks, and to choose your machine learning algorithms, we offer built-in high-performance algorithms. And we provide a one-click way for customers to train their infrastructure. And now with P3D, and we make it easier and faster to run these training infrastructure. Finally, we also provide an automatic model tuner that makes it easy for developers to automatically tune these models and underlying hyperparameters. And finally, to deploy these models in production, you can do it with a single click, and it comes built in with auto scaling as well. And it now integrates with elastic inference. That is one of the reasons why now SageMaker, since its launch, has been used by thousands of developers already, with customers like Intuit, which is a leading financial technology provider in USA. They are the makers of TurboTax and QuickBooks, and they are using SageMaker to do various things like fraud detection models and personalization models, and also look into actually using it in technologies like QuickBooks, where they're able to go through years worth of actually underlying data and mine what are the detections and save huge amount of money for their customers. And using SageMaker, what they have found is the machine learning model development time, what used to take more than 6 months, has been cut down to less than 1 week. That's one of the reasons why you see so many of our customers starting to use SageMaker. Now, I mentioned data as being one of the biggest blocker. Now let's take a look at what SageMaker does to make it easy to remove this blocker of having need for prepared trained data. Now, as I mentioned, successful models require high quality data. Let's take a look at an example of an autonomous navigation system. If I'm a startup trying to build an autonomous driving car, now one of the things I need is high quality training data, where I have pictures of actually the road and then the road signs such as stop signs and traffic lights and pedestrians and so forth. And not only do I need these photos or these images, I need annotated images where I can train the underlying machine learning algorithms to recognize this stop sign looks like this, and a pedestrian looks like this, and other cars and trucks look like this, and so forth. Now, to do all that, you have to build an end-to-end infrastructure for annotating these things and make sure that the underlying deep learning system recognizes this stuff so that next time when it actually runs through these images in the wild, it recognizes a traffic sign or a stop sign or pedestrians or other vehicles and so forth. Now, historically, if I'm actually a startup and trying to build an end-to-end system, now I have to actually build an end-to-end machine learning system for annotation. And then I had to hire a huge number of human labelers who will go through all these images and build these annotated data system. That's one of the reasons now to address this issue. Last year, we launched SageMaker Ground Truth. Now, using machine learning, now SageMaker makes it really easy. So now let's start with the raw data. It's raw data. Now in SageMaker Ground Truth, first you actually pass it through human annotations. Now Ground Truth, it integrates seamlessly with Amazon Mechanical Turk, or you can bring in your own private workflows. Now, Ground Truth collects human labeled data and builds a special custom machine learning model based on the human annotations. Then using that model, now, in future, when you get these raw data, it either can automatically annotate it and convert it into training data, or in scenarios where it does not have the confidence in terms of the accuracy of the annotated data, it sends it to human annotations and then generates the training data. In the scenarios where the confidence is low and it routes to human annotators, it sends it back and kickstarts a retraining of the active learning model. That is, so this way, that means over time, Ground Truth can label more and more data automatically, and only a small percentage of new data will be sent to human annotators. The rest can be done automatically. Ground Truth integrates with different options for underlying human workforce. It integrates with Amazon Mechanical Turk, which provides more than 500,000 workforce. For data which requires confidentiality or service guarantees or special skills of pre-authorized workers, a private workforce of your own employees, then you can bring your own private labeling workforce as well. Or you can also leverage specific third-party vendors such as Imered, Vivitech, Cogito Tech as well to get different kinds of things. Overall, using Ground Truth, now you can actually reduce the underlying cost of generating training data, which removes the blocker for building more and more machine learning models. And that is one of the reasons why we have customers like Change Healthcare or GumGum really excited about Ground Truth, because now they can quickly label training data and get accurate results for their machine learning models with very low cost. Now, let's take a look at the third biggest blocker for broad adoption of AI technologies, that is ease of use. If you look at, now let's take a look at the recap of what it means for SageMaker. You looked at the end-to-end picture. We addressed with SageMaker Ground Truth to make it easy for customers to generate training data. We added things like AWS Marketplace for machine learning. We made it easy for training by using P3DN and so forth. Now, typically, then in the end, we have also made it really easy for customers to do one-click deployment and also train and run the underlying models as well. Now, when we talk about ease of use, customers often ask, how can we tap into Amazon's experience in machine learning? If you look at Amazon, we have built an end-to-end system that is completely machine learning driven for forecasting. Now, let's take a look at forecasting problem. Historically, people think forecasting is a very simple problem. You actually collect data, for example, let's say sales over time, and then you do your best to predict actually what's going to be the sales figures in the future. And if you guess it too high, you end up actually keeping a lot of forecast, or if you end up guessing too low, you end up leaving customers unhappy. But when you look at forecast in general, people think you can actually take one series of data points and then start predicting. In reality, to generate accurate forecasts, you not only have to worry about sales data, you might have to worry about customer access pattern, weather data, and various other kinds of data points to generate accurate forecasting. That is one of the reasons why this reInvent, we launched Amazon Forecast. It's a brand new AI service that makes it really easy for customers to build an end-to-end forecasting model with a few clicks and improve their underlying forecast accuracy by up to 50% at 1/10 the cost. Now, we have customers like Mercado Libre, who's a popular e-commerce provider in Latin America. They are actually excited about using Amazon Forecast to generate highly accurate forecasts for more than tens of thousands of products. And one of the things they are excited about is Forecast makes it easy for them to integrate many historical time series and get to results quickly. Similarly, the other request we constantly hear from customers in terms of making it easy to use machine learning systems or to build high quality recommendations similar to what Amazon has done. If you look at the history of Amazon.com, one of the things we have learned is that there is no single master algorithm for building the best recommendation system. In fact, the recommendation engine we use for recommending products is very different from the recommendation engine we use for recommending music, because for products, we look at what are the category of products customers are interested, what are the past behavior, and then what are the right promotions and so forth. Whereas for music, it's not always about what they have looked at in the past, but we look at what is trending, what are the genre of music they are interested in, and so forth. Similarly, content, the recommendation parameters and engines are different as well. That is one of the reasons why we end up putting dedicated teams that look at various different underlying data features for each of these applications to collect the best set of data and then build an different personalization or recommendation model for each of these systems. Now, having learned all these, one of the things we wanted to do is how can we save the time for our customers to make it easy for them to build a recommendation or personalization model automatically based on their underlying data. To that end, last reInvent, we launched Amazon Personalize. It's an end-to-end AI service that makes it really easy for customers to build a personalization model that improves their customer experience by delivering high-quality recommendations, both at real time and batch as well. So we have customers like Domino's Pizza, who is excited about delivering highly personalized recommendations for their customers using Personalize, where they can integrate Personalize with their underlying data lake and actually develop high-quality recommendations for their customers. Similarly, we have customers like Spool, a leading video analytics platform. They're excited about using personalized to move away from manually curated recommendations to highly personalized real-time recommendations for their customers as well. So as we talk to more and more customers, and they say, hey, dealing with documents, paper documents or PDFs or Word documents, and converting them so that they can actually search and query on these documents has been extremely hard. And we asked ourselves, how can we make it easy? So when we looked at how our customers are handling these documents, historically, this has been done through OCR systems. So we asked ourselves, OCR technology has been around for a long time. So why is it not solving the problem? So now let's take a look at this example. You have 2 columns of text, and in one column, it's purely a bunch of text in different paragraphs. And column on the left, you have a table. Along with text as well. Now, traditional OCR system does not recognize that there are 2 different columns and there is a table. Instead, it just reads all these texts together end to end and produces a text that is even hard for somebody to understand. That's one of the reasons why when companies use traditional OCR systems, they have to employ a huge amount of human workforce to check the accuracy and quality of these OCR output, and in many cases had to probably start from scratch to produce high quality text extraction system. That's one of the reasons why last reInvent we launched Amazon TextRact. Amazon TextRact is a new AI service that makes it really easy for customers to extract text and data from virtually any document. And the goal is to eliminate as much manual effort as possible, in addition to significantly lowering the document processing costs. So let's take a look at how TextRact OCR technologies differ from a traditional OCR system. Now, in the example that I talked about before, now if you run it through the TextRact system, it first understands the overall layout of the document. It recognizes there are 2 columns of text, and in the individual column, now on the right side, it accurately extracts the text and separates different paragraphs and so forth. Similarly, it actually detects the table on the left-hand side. It not only detects there is a table, it extracts the underlying column headers of the table, such as method and number of clusters and so forth, and the underlying values and so forth. So this is how with TextRact, it goes beyond traditional OCR to make it really easy to understand the layout of the document and also to understand various nuanced document structures such as table. Now, when you look at actually traditional documents, well, you could argue that, hey, document processing is easy, but what about forms? In fact, when you look at forms, the challenge with forms is that forms in theory kind of look like, hey, forms don't change that often. In fact, let's take a look at W-2, which is an US tax form. If you look at it, it has various well-set fields and values like customer's first name and last name and social security number and so forth. And in fact, the U.S. Treasury, also IRS, dictates what a typical W-2 form should look like. But in reality, forms don't all look the same. In fact, each employer or payroll system ends up generating different kinds of forms in terms of layout, in terms of structures, and so forth. So now, if I'm building a startup that automatically tries to read many of these W-2 forms, now I have to worry about different kinds of layouts and how different fields and values are laid out in these forms and so forth, which makes it really hard for us to build these forms out. And this is where now TextRact makes it easy. Similar to what TextRact did for documents, now with forms, it automatically understands the structure of the underlying form, and it extracts the field name and the value and emits it as a JSON object. For example, in this form, it extracts the SSN field name and then the value. It extracts the name, it extracts the address, and so on. And that is one of the reasons why now we believe TextRite will make it really easy for customers to use and analyze documents virtually of all kinds. Now, I talked about three biggest blockers with respect to adopting AI: cost, data, and ease of use. And I talked about various technologies that we have done, such as elastic inference and inferentia that makes it easy with cost, and about data with ground truth. And now we have technologies like reinforcement learning that we launched last reInvent. And with ease of use, we launched a whole lot of technology that makes it easy to make AI and machine learning easy to use as well. With that, I'll just end with saying, that is one of the reasons why we call out to say Amazon machine learning stack provides the broadest and deepest set of capabilities in terms of machine learning capabilities, right from expert practitioners to machine learning developers to application developers with no machine learning experience. In fact, in the rest of the conference, from Olivier and others, you're going to hear on various things such as SageMaker and ground truth and reinforcement learning and security architecture. You will hear about Lex, Comprehend, and also our brand new Deep Racer and so forth, and how SageMaker and Deep Racer makes it really easy for developers to learn about reinforcement learning and how to actually apply it to build brand new, cool, innovating applications as well. With that, I will hand it over to Olivier. Thank you.
Thank you, Swami. Very insightful. AWS offers our customers so many different possibilities to make their artificial intelligence and machine learning journey easier. No matter if you just want fully managed AI services in the space of computer vision, speech, language, conversational interfaces, forecasting, and personalization services, or you want to build your own machine learning models using our machine learning services, such as Amazon SageMaker. Remember, with SageMaker, you can build your own machine learning models without writing and building your machine learning algorithm. Just use the ones that Amazon provides you, or look at our AWS marketplace to find many interesting machine learning algorithms which can train models securely with your data in your account. And if you're an absolute data science and machine learning expert, then make use of our extensive AI/ML framework support and all the optimizations we provide you through our elastic and flexible infrastructure platform. Speaking of frameworks, though, it's really important to note that AWS's vision is to be framework agnostic. We always want our customers to use the frameworks of their choice while getting access to the latest and greatest infrastructure. And not only that, as Swami mentioned earlier, we continuously optimize our platform for these frameworks to provide the best and most cost-effective performance for both training and inference. And now with the launch of Amazon SageMaker Neo, we also provide our customers the ability to not only have flexibility on the frameworks they use, but also the hardware they might deploy machine learning models to. For those use cases where you need to push your machine learning models to the edge or remote locations, we provide now an optimized and quick way to compile and optimize models from your preferred machine learning framework to a variety of different underlying hardware providers such as Intel, NVIDIA, Qualcomm, Xilinx, Cadence, or ARM, with more to follow. Now, with all of these possibilities, the opportunity has never been a better one to start your machine learning journey. And given this lowered barrier of entry to make use of machine learning with all the possibilities of AWS, there are plentiful of interesting technology startups that build their AI and ML companies on AWS. Let's have a look at a few, such as Active.ai, who build conversational services for banks and fintech businesses to redefine their future digital strategy. Capillary provides deeper insights using AI-powered retail analytics to develop personalized engagements on relevant channels for their customers. In the healthcare space, Cure.ai designs and develops deep learning algorithms to precisely read and interpret medical images such as X-rays, CT scans, or MRIs. Tessak builds video recognition technologies on top of AWS using machine learning to automate video metadata generation, effectively making video content smarter. Or Unboxed, an AI-driven e-commerce search platform to understand shoppers' intent and connects them with the most relevant products. Or Haptic, one of the world's largest conversational AI platform for customer support, feedback, order status, and live chats. But not just startups, but large existing enterprise customers use AWS to build their AI and machine learning projects and products. For example, Kia Motors, Korea's oldest car manufacturer, produces 3 million vehicles a year to customers worldwide. And they use Amazon Recognition and Amazon Poly to develop a car login feature using facial analysis and voice services. Introduced in CES 2018, this system welcomes drivers and adjusts settings such as seating, mirrors, in-vehicle infotainment based on individual preferences to create a personalized driving experience. Or companies such as Samsung Heavy Industries, one of the largest chip builders in the world. They use an Amazon S3-based data lake to store information collected by their smart ships. The company's smart shipping systems use AWS services to integrate vessel-related data collected from land to sea. With that, they build a big data analytics ship navigation system that improves aftermarket customer service for ship owners. They also use AWS machine learning services, including Amazon Poly and Amazon Lex, to provide real-time alerts to customers about the condition of their ships, and will use Amazon Subramanian to create a virtual replica of the ship cockpits for land-based training and simulations. But now, let's hear from our customers themselves on how they transformed their digital journey using artificial intelligence and machine learning services of AWS.
I'm Jason Blackman, CIO here at Car Sales. Car Sales is the largest online automotive, motorcycle and marine classifieds business in Australia. We are also a global organisation with a presence in Asia and South America, including South Korea, Brazil, Chile and Mexico. To enable this global expansion, we now have a cloud-centric technology platform. Our cloud journey started back in 2013 and we recently moved entirely to the cloud. One of the key benefits is that our rate of deployment has significantly increased. It used to be just twice weekly, but we are now at a few hundred per day. This allows us to quickly build and deliver products to our customers. Car Sales' adoption of cloud-ready technology platform has resulted in improved cloud utilisation, saving costs and increased development efficiency. To improve business efficiency, fraud detection, and to deliver a better overall consumer experience at scale, we have started our AI journey. AWS machine learning services such as Deep Learning and SageMaker has helped our team build AI-based technology more efficiently, without the need for us to worry about the infrastructure. We are always looking for ways to innovate and to make our process more efficient. There are many more AWS services like personalized and reinforcement learning that we're very keen to use. There are so many opportunities to work with AWS early in the development of our products, helping us to deliver real innovation for our customers, now and into the future.
This is Panish Guraj. I work as VP Engineering at Redbus.
I'm Puneet Karamba. I'm working as an engineering manager at Redbus.
Redbus is the largest bus booking platform in India. In terms of our pure bus booking volume, it can also be across the world. We are currently headquartered in Bangalore. We have other offices across the globe in Singapore, Malaysia, Indonesia, Peru, and Colombia. Redbus is a marketplace model. We have customers who want to hop onto a bus and they need an easy way of booking their bus journey. We also have the operators, which is a supply for us, who have a large fleet of buses on their side. At Redbus, we receive thousands of reviews and we wanted to provide a better way to showcase these reviews to our end customers. The main architectural goals here was to provide these user-generated content in a much more simple way in terms of tags so that he can make an informed decision. Secondly, we wanted to solve at scale because we have unsent tons of data. Thirdly, we wanted to ensure that for different kinds of reviews, we wanted to have different variants or in terms of modeling, like different machine learning models need to be available so that we can quickly iterate and give it to our end users.
Amazon SageMaker has been a revolutionary step in solving this problem where we are able to save a lot of development time in terms of the issues which we had on our local machines, and porting that same thing to Amazon SageMaker has been helpful to do a lot of continuous iterations in training the model itself and evaluating the model. We have built this use case around scikit-learn, which comes within the framework of Amazon SageMaker. We have used the random forest classification algorithm to do our multi-label classification. We have hosted using the bring your own model technique of Amazon SageMaker.
The benefit of using AWS SageMaker has been, number one, conversion rate has improved by 5%. Our click-through rate has improved close to 20%. And finally, the time to go to market has actually reduced from a couple of months to almost a couple of weeks now. One of the business objective was to scale during a lot of our peak periods flawlessly, and AWS definitely has ensured that we are able to handle that well at scale. Redbus has been the earliest adopters of AWS in India. Just when the cloud was picking up, we made a good choice of getting onto the AWS platform. The plug-and-play architecture of AWS provides an innovative platform for the tech community to provide seamless user experiences. Almost all our workloads, both from development and entire production, work on AWS systems. We have been adapting to the latest offerings that are coming out there.
My name is Cindy. I'm the co-founder and CEO of Sunday. We're a multi-line insurtech based out of Thailand with a fully integrated sales and service platform. And the idea is to use data and technology to completely redefine the entire insurance value chain. The way at Sunday we see insurance is just that. We believe that we're building a company which is adaptive. It's absolutely very important for us to be able to adapt to the risks that we're trying to cover and also offer protection to our customers that way. A key differentiator in the market today is actually our AI and machine learning capabilities, where we're able to, and flexible in fact, to price and provide any type of products to any type of customers in real time, as well as a tailor-made coverage. Machine learning and data science goes to the heart of our business model. It's the core of it. We use it to create new products, to constantly improve and reiterate our pricing. And in fact, I believe that actually the entire insurance value chain can be redesigned if we actually use data to power it to make smart decisions as well. At Sunday, we've created a machine learning algorithm which is running on Amazon EC2. And what we've done is actually we've trained our machine learning model. Whenever a customer quote comes in, our machine learning algorithm, which is powering our risk pricing engine, performs and is conducting billions of data points calculation using the historical data currently stored on our RDS. We deployed this machine learning algorithm and delivering our recommended quote and product to our customers. We've started to use machine learning to sort of automate our entire claims assessment process. We've started to extend our AI and machine learning capabilities to train our deep learning frameworks using SageMaker. And what it does, it predicts motor claims assessment in real time. So now we're able to predict the location of where the damage is on our vehicle, to predict the motor claim severity, as well as the estimated repair cost. The key benefits working with AWS is supported us to provide more affordable coverages for our customers. So deploying and having our AI and machine learning platforms running on AWS has allowed us to, for instance, generate up to 20% savings in motor insurance that we're currently offering to our customers. Our relationship with AWS has been very, very powerful. We've been very quick to adopt new technologies, constantly being rolled out by AWS. So we believe that there's been a very fruitful relationship, and we look forward to more.
What great stories. And I'm certain there are plenty more to follow with all those new and exciting capabilities. Remember, with AWS, you can get access to advanced AI and machine learning capabilities without any prior machine learning knowledge or expertise. Use the broadest and deepest set of machine learning and AI capabilities for your business and retain full choice and flexibility with your machine learning frameworks and infrastructure used. And of course, as always, including this online conference, will provide you with plenty of learning tools and resources. Now, don't forget to visit the demo arena and watch how machine learning is used in real-life applications. Get your questions answered by our AWS experts through this platform anytime. And for more information about machine learning on AWS, you can also visit our website on aws.amazon.com/machine learning. Thank you again for attending, And we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think. Enjoy the rest of your AWS Innovate online conference. And with that, let's go build.